to lesson 6.3 of Unit 6. Here we're going to introduce you another way of approximating these areas, maybe a bit more accurate than using a rectangle. And so if you come along and look with me, let's take a look at how we can approximate areas using trapezoids. Okay. I actually do think a trapezoid is more accurate than using a rectangle, for the sole reason that, hey, it's a slanted side. Here are two visual pictures of a trapezoid. I don't know if you've seen this one like this before. We've got a height, and notice in this case the two parallel sides have different lengths. And the idea then is you're really just taking the average of those two parallel sides of different lengths. That's the 1/2 and the b1 plus b2, and then multiplying it by the height. However, for us in calculus, most of our trapezoids do not lie horizontally. They stand vertically. So instead of having a height, it's the height that actually does change. So h1 on the left side, h2 on the right, and that's what we're trying to find the average of. So really you're trying to find the average of the heights, and then we'll multiply it by the width to actually figure out the area of a trapezoid. So if you understand that, then let's go take a look at our first example. Here, once again, I'm going to ask you to approximate this lovely integral. And in this case, I want you to add the areas of 5 trapezoids that are shown in the graph at the right. So once again, I'm asking you to find the definite integral. This is an approximation, so please use the approximate sign. And let's go ahead and try to find these areas. For number 1, well, that trapezoid is very interesting. It looks like a triangle. Yeah, so a triangle could be a special trapezoid with one of the heights being equal to 0. So you're looking at the formula, that'll be 1/2 times the width. The width in this case is 2. And then the heights are 0 on the left and also 4 on the right. Looking at trapezoid number 2, here it is. Interestingly enough that the widths are not the same in this case, so it looks like it's 3. And our heights are also different, 4 and 3. There you have it. We'll use trapezoid number 3 here, plus 1/2. Its width is 1. Noticing the height on the left is 3, the height on the right is 2. Interestingly enough, number 4, the trapezoid looks like a rectangle. So yeah, you could say a rectangle is also a special type of trapezoid, where both the heights on the left and the right are the same. And finally, you have your 5th one here. Width is 2. 2 different heights, and there you have it. Okay. You can go ahead and simplify and calculate if you wish. I'll bring out my trusty calculator. Hello, calculator. Half 0.5 times 2, that's just times 4, plus 3 over 2 times 7, plus 0.5 times 5, plus 1 times 4, plus 1 times 7. I got 28. Okay, and I hope you can see visually that this is probably a much better approximation than using just regular rectangles, because you'll see that, yeah, I missed out here, but I had a little bit over there, so it kind of balances out. Cool. Alright, so just a note here, if you do forget the formula for trapezoid, you can always draw your areas as rectangles and triangles. What do I mean by that? Let me focus in on trapezoid number 2 from above. You see how I can split this up? Rectangle in blue, triangle in green, and just add up the 2 things to find the trapezoid area. Okay, let's try example 2. Okay, using 4 trapezoids of equal width, can you find an approximation for the area of this curve, y equals x squared? Quickly do a sketch, please. Whee! Bounded below by the x-axis, on the left by 0, on the right by 2. So, in essence, I think what you're trying to do is find the area under the curve between 0 to 2 of x squared dx. In this case, once again, it's an approximation. I know you can do this by algebra, but let's just, for the sake of our example here, find an approximation. Because it says 4 trapezoids of equal width, hopefully you can say that, hey, the width is the difference between b minus a divided by the number of rectangles. So each one has a width of a half. And if you think about what you're doing then, you're trying to connect them together like this. Here's 1, here's 2, here's 3, and here's 4. So 4 trapezoids that you have to calculate. All right. I'm going to look at the first one here. Once again, it's a half. The width is a half, and the two heights are 0 plus, now a half squared is just a quarter. So once again, I got this by taking 1/2 and squaring it, plugging it into the formula y equals x squared. Next one, same idea. 1/4 plus 1, right? This is 1 squared. Gonna keep going, 1/2, 1/2, 1 plus, now it would be 3 over 2 squared, that would be 9 over 4. And then finally 1/2, the width is still 1/2, 9 over 4, and the last point here would be the y value equals to 4, is it? No, sorry, 2 squared, yeah, so 4. Good. Maybe you're thinking, hey, Mr. Lee, this looks kind of hard to calculate, but I want you to understand, look, there's a half and there's a half everywhere. Interesting. So let's factor out that, okay? The 1/2 and also the 1/2. Okay? And let's see what we're left with now after we factored that out. I'm left with a 0 plus a 1/4. I'm left with a 1/4 plus a 1. I'm left with a 1 plus a 9/4, and also another 9/4 plus a 4. Notice here that it looks like all the terms or values in the middle are doubled. Yet my values at the end point are not. Can you think about why that is the case? Hope you can answer that, because at the end points we're only using those heights once. Every single point in the middle we get to use the height twice, because there's a trapezoid on the left and the right of that particular point. In any case, so we can now hopefully calculate this much easier. 2 times a quarter is a half plus 2 plus 9 over 2 plus 4. 9 over 2 plus 1 over 2 is 10 over 2, that's 5. 5 plus 2 is 7, plus 4 is 11. So this is just 11 over 4. Okay, this is our approximation. Done. Now this gives rise to what I want to say to you now. So when using trapezoids, if the subdivisions produce equal widths, which is what we did in the previous question, then you can actually use this lovely formula. That 1/2 is there, the width is there, those are the two things we factored out. And now notice all of these here are just the heights. The heights used, right? H sub 0, that's the leftmost height. So left height. And H sub n is the rightmost height. And these are all the heights in the middle. Heights in the middle. And why is there a factor of 2 in front of all of those in the middle? That's right, it's used twice. So if you want to memorize this formula, you can. If you just understand the concept, that's even better. And now let's just do example number 3, and then we'll be done. So use this trapezoidal rule, okay, with 4 equal subdivisions to approximate the area shown. Notice in this case I gave you a table of values for the y values, so just look there for those values. The width is still going to be 50 minus 10 divided by 4, so that's 40 over 4. Each width is equal to 10 units, which totally makes sense. So the area here, as an approximation, will be 1/2, and then my width is 10, and then now it's just all those heights. So I'm going to take a look at my leftmost height. That would be the y value corresponding to 10. That's 1.8. Then I'm going to look at all the other heights in the middle, and I'm going to double them. So 2 times 2, 2 times 2.5, 2 times 3.5, and then your right height, once again, just using it once, plus 2.2. Okay. And then if you want to actually calculate this, this will be what, 5 times, gotta get my calculator again. Where's my calculator? Hello, calculator. 2 times 2 plus 2 times 2.5 plus 2 times 3.5 plus 2 times, or 2.2. That's 20. So in this case, 5 times 20 equals to 100. And that's the approximation here. Okay. So note the similarities and differences between the trapezoid rule and the formula for finding Riemann sums. The idea, once again, is you're adding areas by multiplying a common width by a sum of the heights. It's just when you're using trapezoids, you have half the width, but twice the height. Alright, that's it. Hopefully you can now start your assignment below.